Okay, this is the 3.B.3 homework. 4.44. We were asked to find the half reactions that go together to make the reaction that is written. So the first reaction was iron and oxygen making iron oxide. So in that reaction, iron goes from iron metal neutral to +3 by losing 3 electrons. O2 goes from neutral to -2 by gaining 4 electrons. Now, if you take this reaction times 4 and this reaction times 3 and add them back together, you get the reaction given in the question. Chlorine, Cl2, going to 2 Cl minuses by adding 2 electrons, reduction rather. Sodium going to sodium +1 plus an electron, oxidation. Double this reaction and put them together, you get the reaction given in the question. Silicon goes to silicon +4 by losing 4 electrons. Fluorine gains 2 electrons to go to 2F minus. Double the second reaction, add them back together, and you get the reaction given in the question. H2 becomes 2H plus 2 electrons. Cl2 plus 2 electrons becomes 2 Cl minuses. Of course, the H plus and Cl minus together make HCl. In 4.46, we were asked to find the oxidation number of P in all of these hydrogen, phosphorus, oxygen compounds. So we do that by letting hydrogen be +1 and oxygen be -2. Adding them up, we get +5 for P on A, +1 on B, +3 on C, and then +5 for D, E, and F. Now we have 4.54. Now we did not specifically go over activity series, but activity series are very similar to the standard reduction potential chart. It tells you what reacts with what. Figure 4.15 on page 134 is the activity series they wanted you to use. That activity series tells you that copper does not react with water and does not react with acids to produce hydrogen. So if you tried to put copper with hydrochloric acid, it should be no reaction. Over on the page 135, they show a halogen activity series, which basically says that iodine is the least reactive and fluorine is the most reactive. So iodine cannot kick bromine out of sodium bromide because bromine is more reactive than iodine, and so this is going to be a no reaction. On the activity series, it does show magnesium being more reactive than copper. So if copper's in a compound, magnesium wants to kick it out. So Mg plus CuSO4 yields Mg plus CuSO4. Sorry, is that right? Mg plus CuSO4 yields MgSO4 plus Cu. Magnesium is more active than copper and will kick copper out of the compound. Chlorine is more reactive than bromine, more active than bromine, and can kick bromide out of KBr, making KCl plus Br2. These are all single replacement reactions. Okay, then we're down to 492 and 494, which were both redox titrations. So we have 5SO2 and 2MnO4 minus plus 2 waters makes 5SO4 2 minus plus 2Mn plus 2 plus 4H plus. We take the liters times the molarity for the KMnO4. That gives us the moles of permanganate, MnO4 minus. The moles of permanganate times 5/2 gives us the moles of SO2. And then we change the moles of SO2 back to grams by multiplying by molar mass. And we get 0.00948. Okay, 494. 4.94. Permanganate and hydrogen peroxide reacting in a 2 to 5 ratio. Here we have the liters times the molarity gets us the moles of MnO4 minus, times 5 over 2 gets us the moles of hydrogen peroxide, then dividing by the liters, 25 milliliters, 0.025 liters, gets us 0.06 molar for hydrogen peroxide.